Hey again, everybody. Let's do one more good application kind of problem. This is a good AP style problem too, where it's not 100% clear. The information that they're giving you is leading you to where you need to be. So you probably see already. They give you a derivative. So great. You're trying to find the original, of course, right? Find a function f where this is f prime. So no big deal. I'm sure without even reading the whole problem, you've already started in your heads. You're like, okay, if f prime is 12x plus 2, I'm going to use the new sort of reverse power rule and figure out what f of x is. Great. You even can do the simplifying in your head. X squared over 2, so that becomes 6x squared plus 2x plus c, done deal. Unfortunately, they want the actual function f, which has this requirement as well. The the line negative 2x plus 1 equals negative 1 is also tangent to that graph. Well, that means we need to know specifically which function this is in order for that to happen. Well, in order to do that, we need some kind of initial condition. I need a point that's on this curve so I can lock in what c is. Otherwise, it's like that whole y equals x example. Is y equals x here? Or is it y equals x plus 5? Or is it y equals x minus 3? In the end, the derivatives are the same, but I don't know the c value yet. So I need to kind of interpret what this information means here. This, the line negative 2x plus y equals negative 1 is tangent to the graph of f. If it's tangent to the graph of f, we should be able to make the connection that it has the same slope. All right, well, we have the slope right here. F prime is 12x plus 2, but what's the slope of this line if it's supposed to be tangent to that curve? Right? It's supposed to be tangent to the original f, which has this derivative, so which means the slope has to be the same. So if negative 2x plus y equals negative 1, then y equals 2x minus 1, and the slope would be 2. So the slope of the tangent line is 2, which means the slope of the curve must be 2. If the slope of the curve must be 2, then the derivative has to be 2, because the derivative is the slope of the curve at any x value. So that's kind of the key step right there. We need to realize that this derivative is actually 2, because the derivative and the slope of the tangent have to be the same. Okay, at that point, right? At the point of tangency. So if the derivative is 2, then 12x plus 2 must equal 2. That means 12x, of course, equals 0, which means x equals 0. And before you start thinking something went wrong, x can be 0. There is a point on the graph where x is 0, right? In fact, we can figure that out. If x is 0, then the point that's on this tangent line must be the same as the point that's on this graph. So if I plug in 0 here, of course I'm going to get c. What's that going to be equal to? It's going to be equal to whatever the value of the tangent line is at 0. So y of 0 is going to be, obviously, 2x minus 1. So it's going to be negative 2 times 0 minus 1. So that's going to be negative 1. So the point 0, negative 1 is on the tangent line, which is here, which means it also must be on the original curve here. And because it happens to be 0, I can plug in zeros very quickly and see that c must be negative 1 for that to work. Right? I'll do that in another color right underneath. So f of x must be 6x squared plus 2x minus 1. Because if you plug in 0, you should get negative 1. So this function right here, the blue one, has a derivative of 12x plus 2. The slope is 2 at 0. Excuse me, yeah, the slope is 2 at 0, right? The slope is 2 at 0, which means that the tangent line has the same slope at 0 as the original function has at 0, right? So that's the connection you need to make, is that the slope is 2 means the derivative is 2, and whatever x value that occurs at, which in this case was 0, must be that magical x value that gets us our final point, which locks in our c value. All right, so hopefully that helps with those kind of problems. And again, if you need any help, you just let me know.